Hey, 4,700 students and 6,700 students. Welcome to Module 3. We're going to be focusing on how to evaluate technology. And I'm going to go through kind of a short lecture right now that you guys can watch and listen to that kind of gives you some introductions to what I'm thinking about when talk about technology evaluation and some of the tools we're going to use to help us evaluate technology. So really what this module is going to be about is thinking about how we use technology effectively and efficiently, and what I really mean by effectively and efficiently. So when I say effectiveness, I really don't think about effectiveness in the same way that we see in education so much. We want to see if a teacher is being effective, where the product of effectiveness is how well our students perform. To me, effectiveness is not about so much about results, and it's not about how well our students do on assessments. It's not about our own evaluations of whether an effective teacher is done by how we are performing on some evaluation done by administrators. No, effectiveness is not really the product of work, it is the actual work that we do. Effectiveness is about what we do, not the results of what we do. So to me, effectiveness is really about doing things the right way. It's doing what is best for our students, doing the things that are going to help them learn, help them meet them where they're at, and figure out a way to get them to where we want them to be. It's doing what we can to help them learn. It is doing things the right way. Effective teachers do things the right way. And with effectiveness usually comes efficiency. They go hand in hand. In order to be effective, you also really usually have to be efficient. But efficiency is not what we traditionally think, at least not the way I view it. Usually efficient people are quick with doing things, but that's not the reason why. It's not because they're efficient. It's not just about making good use of your time, although you'll see efficient people do that. Efficiency is truly about making right decisions. If you see people that are efficient, it's because they make the right decisions about how they spend their time. And they make the right decisions so it seems like they're doing things quickly. Efficient people make the right decisions. And when you go hand in hand, great math teachers, at least the ones that I've seen and I've had and I know, they're effective and they're efficient. They do the right things and they do things in the right way. They make good decisions about what they do with their students, and then they instruct them and implement those things in ways that meet the needs of their students. And so this is so true when it comes to technology. All right? We have to be smart about what we choose. We have to make good decisions about what we use with students, and we have to use them in the right way. You see, there are all of these different applets out there. If you Googled a topic, you're going to get hundreds of thousands of hits. And even if you just Google the topic with applets, you're still going to get thousands of hits. There is so much out there everywhere. I know teachers that go to Pinterest, they go Teachers Pay Teachers. There's so much out there, but the question is it any good? What is good? Is this applet better than this one? How do I know if this worksheet is good? So the question is, how can we decide whether something is good or not? So Dick developed these ideas of fidelity, whether the technology is going to remain true to what it's intended to do. Okay, he developed these ideas in not really for teachers to use, but really for people who design mathematical software. He wanted designers to think about, is the mathematics that's being displayed, is it faithful to what's intended? Is the applet allowing students to think and show how the students are thinking? And is it allowing students to engage in the mathematics in meaningful ways? So we're going to go through each of these three different kinds of fidelity. I'm going to describe and then provide an example from an applet that may not have the kind of fidelity we're looking for. So mathematical fidelity. Mathematical fidelity is about how accurate does the tool allow you to represent the mathematics. Is the mathematics being accurate? Is 2 plus 3 actually 5 in the applet, or is it saying 4 or 6? Okay. Does it represent the mathematics accurately? If you're constructing a triangle, Does it actually sum to the measure sum to 180 degrees? If it says it's a right triangle, is it overconstructed or underconstructed, to use the terms we use in Module 2, right? Is it being accurate, all right? How well do the objects represent the underlying mathematical ideas? Are all cases possible? If we're looking at the triangle inequality theorem, and the triangles that can only be created are with whole or with using integer lengths, well, then we're really missing out on anything that are rational lengths. And so, are all cases possible? And then, could students develop a misconception about the mathematics? All right, what kind of things are going to hinder them and develop wrong ideas? Okay, so I want to look at an applet here. It's called Hungry Fish by Motion Math. I love Motion Math. It's a great applet. This is a video that introduces you to a game that my daughter really loves to play. And so I want you to listen and watch. I want you focusing, while you're watching, I want you focusing on how the mathematics is being displayed.
Hungry Fish, featuring a fish who eats numbers. In this case, 3. The game also features instant addition. Touch a 1 to a 2 and you get 3. It's an engaging way to practice addition, made possible by multi-touch. To win, you must find different ways to add up to a sum. For example, what are all the ways to make an 8? If you don't feed your fish, it shrinks. Feed it enough numbers, it'll grow, you'll win the level, and you'll get to customize your fish, unlocking new colors and new fins.
Isn't that awesome? You get to unlock the levels and get new colors, new fins, and my daughters love it. They love to play this game. Okay, my 8-year-old have kind of gotten past it, but my 5-year-old really loves it. All right, so let's think about the mathematical fidelity here. How is the mathematics being represented? All right, the fish eats this 3, right? Then it pops out a 2 and a 1. Now, how is the mathematics being represented here? Do you see any problems with the mathematical fidelity of this applet the way it's done? Look at this. You have a bubble with a numeral 1 and a bubble with the numeral 2. Well, what do we see? Well, the bubbles are the same size. If this is supposed to be a 2 bubble and this is a 1, shouldn't the 2 be twice as big as the 1? And so that seems strange, right? And then what does this bubble with the 1 indicate? It's a numeral. These have numerals in them. And so when they combine them together, another numeral pops out, 3. Now, because we know addition, we understand what's going on, but addition actually has objects. This is supposed to have like 1 object and then 2 objects, right? So a set of 1 object and a set of 2 objects, and when you combine those sets together, we get a set of 3 objects. But nothing's changing, right? Just the numerals. So what kind of misconceptions? For my for some younger children, this is very abstract. The idea I put this one together and this one together and a new numeral pops up. What is that about? Okay. So how well is the mathematics really being represented here? So at NCTM a few years ago, I was able to meet the designer and the owner of Motion Math and talk to him about this problem. And we had a really great discussion about it. And I said, you know, this isn't really very mathematically accurate. And he said, I know. That's been the one complaint from mathematicians. And I said, well, what are you going to do to fix it? And he said, well, we've done a couple things. One, we put a number of objects next to the fish, and then we can combine numerals, and then we can combine these bubbles with the sets of objects. And so now they've changed it and made it much more mathematically faithful. It has much more mathematical fidelity. I asked them about the size of the objects, of the bubbles, if he ever thought about making this 4 times the size of this one. And he said he did. They did, but the bubbles would dominate, and there wasn't a really good way of doing that. And then it really wasn't something, you know, a fish wouldn't eat a giant bubble. That doesn't make a lot of sense. The idea that fish are eating bubbles anyway doesn't make a lot of sense to me. But they made some changes, and now this is more mathematical, has more mathematical fidelity. The second one is cognitive fidelity. And cognitive fidelity is really about thinking. Of course, it says cognitive, right? But it's really about how students are thinking as they're using the technology. And one of the things we want to think about is, does the technology allow the students to do the mathematics in ways that they're thinking about the mathematics? Can it reflect reflect how they are thinking? As a teacher, can I see how the student is thinking? All right. So I want to look at another applet, and this is also by Motion Math. And I want you to think about, what are the students thinking about as they do this applet? Okay. So you can see this game is actually neat. It's supposed to teach place value to young children, and they use frogs as the whole unit. Um, and it's actually really neat. You can't see it down here, but they'll do tenths on some kind of bug, and then hundredths by even a smaller bug. And then there's a dog that you can't see, that if you zoomed out, that's the tenths place, and like a rhinoceros is the hundred, and something else is the thousands. But the idea is to use animals to represent units in a place value system. All right, but how are the students thinking as they're playing this game, right? How are they? What are they thinking about? Well, they have 0, 1, 2, 3, 4, 5, and it tells you to scroll. And then there's a blank, and you pop the bubble, and then it goes in. And then we get 19, and we start scrolling and scrolling. Oh, there's the blank. Let's pop it there, and it goes to 19. And then I get an 11, and I keep scrolling until I find a blank, and wow, that's correct. What are the students thinking about? Well, they're thinking about find the blank, right? This is not reflecting their cognitive actions. If I'm seeing this from a product, and it's like, oh, my student knows place value, they can put the numerals where they belong in order. But honestly, is that what they're doing, or are they just playing find the blank? So does this have a lot of cognitive fidelity? Not really. The last one is about pedagogical fidelity, and this is really whether the technology allows to do the mathematics with limited distraction and misunderstandings. All right. The idea is, is the technology allowing students to learn mathematics in ways with limited distractions? All right. Is it limiting their thinking? Is it providing opportunities for them to really engage? Are they a silent observer watching a video, or are they actually getting in the midst and being able to think mathematically? Okay. Is there something that distracts students from actual learning? So these are the kinds of things that really teachers, and I've done research on this, teachers actually are more inclined to think about as they evaluate technology from pedagogical fidelity, looking at whether it allows students to engage in the mathematics. All right, so we're going to look at an applet. It's not one by Motion Math. It's just another one. And I want you to think about, what are the students learning as they're engaging in this applet, and does it allow them really to engage in the mathematics in meaningful ways? And I lost. Oh. So, how does this allow students to engage in the mathematics here? All right. Well, it's a fun little game. You get to pull a rubber band back or slingshot this guy. You try to hit. You see the addition problem up here in the left corner, and you have to solve the addition problem and show that you got the right answer by sending this alien worm toward the bubble. And if you get it, you get awesome. And if you miss, you get three. You get three guys, and you try, right? But at the end, what do you notice? Well, I'm aiming at 3. I've got the right answer, right? But there's just no way I can get it. Keep trying, keep trying. And so I finished. And so what was I really learning or engaging with here? Was I really engaging with mathematics? Or was I really engaging in, well, some kind of quasi-physics, right? I'm learning about how the rubber band and angles and trajectory and force and those kinds of things, but I'm actually engaging in the mathematics that I really need to learn, which is, seems like addition. It doesn't seem that way. It's lost its pedagogical fidelity because I'm not engaging in the mathematics that's probably desired for learning or what it's intended to help students teach or really intended for them to practice. Okay, it's a fun way to practice, but how much mathematics is really being practiced here? And how much of a deeper understanding are they gaining from it? It's not much, right? So it lacks pedagogical fidelity. So in this module, I want you to do a few things. The first thing is I want you to read an article that me and my team have written about evaluating technology or teaching mathematics. It goes into more depth on using the fidelities and gives some examples of looking at fidelities. All the examples that I just showed you were from elementary school, but the ones in the article are look at the triangle inequality theorem and some ideas of evaluating technology using the fidelities on a middle school topic. So I want you to read that, and then I want you to do an assignment. And so on ELC and on the class Weebly is the assignment that I want you to evaluate 4 different applets that can be used to teach the mid-segment theorem. And I want you to use Dick's fidelity as somewhat of a criteria for evaluating these. And you see we watched that video on Module 1, and there goes my phone, distracting me from what I'm doing right now. Great. Well, this is a one take, and I'm not doing this again. Right, we're talking about the assignment, and so you're gonna do the mid-segment theorem. And the mid-segment theorem says if you take any triangle and you connect the midpoints, 2 of the midpoints, the segment is half the length of the segment that is on the triangle, and it's parallel to that segment. That's a horribly worded way to say the theorem, but you can find it online if you need to. All right, so you're going to do this assignment. You're going to evaluate the 4 technologies. So in your analysis, I want you to evaluate them using the fidelities. I want you to include a description of the features of each of the 4 tools that you think are beneficial and ones that you think are drawbacks. And also, I want you to think about the questions they're asking. Because a good question can make a bad applet really good or a good applet really bad. So think about the questions as well. And then I want you to kind of provide some kind of comparison for the 4 tools. And in those comparisons, then I want you to pick which one you would use with high school students. On the assignment description, I included the geometry standard. That's actually a 9 through 12 standard. I think it's just to prove this theorem. Think about this as an entry point to the proof. And then you're going to upload your evaluation to ELC when you're done writing this little paper. Okay, the rubric is on the description. And then I want you to do a flip grid. A flip grid is a new technology that I've never used with a class, but I'm really excited that you guys get to use it. So what you're going to do is you're going to go to this website. It's on the Weebly. You're going to enter this password, and you're going to click the green plus sign to add a response. And what flip grids is, it's a video response. I've been reading through your Module 1 discussion board responses. There goes that phone again. I just need to silent it. And it's a lot to take in. You guys are doing a great job. But I think it'd also be cool to have some video responses so we get to see each other and hear each other and know each other. And so what I want you to do is you're going to create a 90-second video and tell us why you chose, which tool you chose, and tell us why. You have 90 seconds to do this. And then once you finish uploading your video, watch some of your classmates' videos. And see if they chose the same one as you and why, and if they chose a different one, why they chose the different one. All right, and that's it. So I will see y'all later.